Good morning, good afternoon, and welcome to this conversation on core optimization and traffic management. This is for a report from Sensafili in collaboration with RCR Wireless News. Today, I'm talking to Anil Singh, the Director of Product Management for the RAN at Guavus. Anil, thanks for being with us today.
Thank you.
Okay, to get started, can you tell us a bit about what is it you do and what is the Guavus does in this environment?
Well, Guavas has been around for about 7 years now. We are a big data analytics startup. We have been focused primarily on the telecommunications domain and providing products around a wide variety of solutions within the telecommunications arena for both wireless service providers as well as the regular classical wireline and cable service providers. At Guavas, I'm responsible for end-to-end life cycle of our analytics products, which are catered around the mobile network. What this includes is any analytics products which related to the wireless access technology. While doing that, my analytics products are designed to focus on primarily two things. It's both the end user ease, which would mean the ease to use, to deploy, manage, integrate, as well as investment conservation. So any product that we bring onto the table, we want to have an incremental value to that, and any investment that an operator makes with us, it's both future ready and covers a broad set of use cases.
Yeah, so it's interesting because you work, you're trying to optimize performance both for fixed networks and mobile networks. What's special about mobile networks that you have to do differently?
The mobile network, especially the wireless part of the wireless network between the handset and the base station, so as to say, or the serving node, is actually the beast, which creates the majority of the difference between these two set of service providers. Mobility, which over time has evolved from just being mobility for voice into mobility for data and various types of networks, whether it was the classic cell sites to now consumers moving in from the wireless network on the small cell to DAS networks, to Wi-Fi, and back into the macro cell network. All of this adds a huge level of complexity in network management.
Yeah, and with the complexity comes the fact that you have a lot of data, a lot of things to keep track of in order to optimize performance. So operators, typically when you talk to them, they have the sense that they're overwhelmed with all the data that is out there. Mm-hmm. How do we deal with that?
So you're right. As the networks grow and as the types of services that are being offered on these networks continue to evolve, and right now are changing faster than ever before, the amount of data, or the volume of data typically, which is associated with what is quoted as big data, becomes a big issue. Now, over time, this definition has changed quite a bit from just not being large volumes of data, but also different types of data, different velocities of data, because different data sets arrive at different time points. They are either structured or unstructured. These sorts of complexities add to the pain that an operator would have when they start looking at combining all these data sets together and extracting actual actionable insights out of this. And actually, Guavas 6 years or 7 years ago, when it was conceptualized, was actually born, for these, like literally. So our philosophy has been that we analyze data first and then store any other data that's needed. So what that helps us do is that whenever data is created or at birth, we have the ability to, so as to say, smart filter. We can identify whether the data is relevant or irrelevant. And when I say irrelevant, 90% of the data today is generally used for reporting purposes. If you're just reporting it, you don't need to store that data. And for occasions when there are anomalies in the network, now I'm assuming that 10% of the time there is something wrong with the network. I hope that this number is much less than that. But let's say for the sake of argument, if that being the case, then the system must adapt and learn. The system needs to know that something went wrong, and now I need to start storing higher granular data. But when nothing's wrong, I need to start aggregating the data for reporting purposes. And Guavas brings that neural intelligence into the network at data birth.
Yeah, and so this is important because you're flexible and you change depending on the network conditions. Now, what that means is that you need to work in real time. It's not just after the fact, looking at the data from a month before. So how important it is to move to, because moving to real time also adds complexity, for an operator. How important it is to do this in real time?
Well, real time, so I should say, is pretty interesting because the whole concept of quote unquote real time can be misleading. Misleading because by the time you take action for an event that may have occurred, the event may have already passed. Best you could do is minimize your reaction time to certain things. If you want a system which is truly real time, you would almost always have to predict an event to occur, and just enough time for that prediction that compensates for lag of processing, reporting, transmission, and any action that needs to take place. I don't believe any such system exists today. Anything which is feedback based, meaning an event occurs, you take a feedback, the feedback executes, an action comes back. All of this takes time. It takes time for you to do, and by that you lose the definition of real time. What we do is we try to make things in near real time for whatever action. Now, if you were to think about NASA's definition of real time, right? How would NASA define real time? NASA defines real time as the time it would take to save a human life, which means if an astronaut is, light years away, and for them to transmit data back to you and you had to take a corrective action, they should have enough time for that astronaut in mission critical conditions to save life. How would you value anything that you are doing to the value of life, right? So if you mean customer experience must be conserved, or any service which is affecting a broader user group needs to be conserved, this timeline for reaction is typically anywhere from under 15 minutes. It will take even some time to dispatch a guy to go out there, make some changes, or to do something remotely. Even for a remote electrical tilt to happen, it takes you a minimum of a few seconds to do that. So Guavas technology enables you to work things in real time. A lot of our products are catered for this near real time use cases. We have responses times to under 500 millisecond if need be. But oftentimes we find that most of the controllers do not have that amount of reaction time, that once we serve that intelligence back, they can react on time for make things to happen. So hopefully that gap closes out in the near future.
Yeah, but I guess that the trend is clear. You just try to move closer and closer to real time, and sometimes you don't need the millisecond real time.
Absolutely.
It's the saving the life that matters. It's what you're trying to accomplish that it's important, and you need to understand. And as you say, you're going to be allow the mobile operators to drill down only when needed so that they don't get into too much complexity. Can you give me an example of how that could happen for an operator?
So for an operator to move into real time versus, let's say, not real time. Now, if it's a highly mobile environment, and then this goes back to a self-organizing network kind of a scenario. There are checks and balances built into the network to try and conserve a call, right? The first and foremost thing is the ability to save a call, whether it is a data call or a voice call. If you lose that call, do you have the ability to come back online very quickly? And for the end user to not feel that sort of a delay in any application that he or she may be working through. So let's say if you are looking at a video conferencing or a voice over IP kind of application, you have tolerances built in that can last you from, anywhere from up to a second which means that you can miss some frames and then all of a sudden you can blast these frames back to the customer. So you'll often find when you are talking on the phone, suddenly there is a speed up in what the end user on the other side is trying to speak. These are all actions to conserve the call itself. In terms of things which do not require real-time capability, you could be looking at things which are more on the care side of things. So for example, you have a user who has gone through a scenario where his call was dropped or has been repeatedly been call dropped. You tried your best to conserve the call if possible, which is the real-time aspect of management. But the non-real-time aspect of management also means that the customer still needs to be talked to, still needs to be sensitized, still needs, you need to make sure that you are making the first contact with the customer in letting them know, hey, we knew that the call was dropped and it's been happening for the past 30 minutes or for the past 1 hour. And here's what we are doing to help you. Some of these systems can be automated, where you send off a text message out to a customer, let him know that, such and such is happening, which may or may not be real time, meaning event has occurred in the past. You just sent it 10 minutes down the road. So the user does feel that, yes, somebody cares about me. So these are two classic applications that we see when we start thinking about real time versus near real time or not so real time basis.
Now, traditionally, the type of data that mobile operators look at to optimize and to understand what's going on in their network is our network KPIs, average across the whole network, or specific to an element. But there is an increasing awareness that that's not really enough. We need to look at QoE. We need to look at new metrics, and that obviously complicates matters. How Guavus, how are you doing in dealing with different data sources? What are they, and how do you combine them together? How do you map them onto each other?
So that's a very interesting question, and actually, I'm glad you asked that, because that's exactly where Guavas shines. The use of KPI as the first beacon of actuality, meaning something just went wrong in the network, and this is how I found out. In 15 minutes aggregation, I found out that there was a 2% drop call rate, or my PRB utilization just went off the roof. While we use the KPIs as the initial indicator, there are a lot of things surrounding that event, either a precursor to it or at that same time, that if aligned will give you more intelligence. So it's not just that I know something went wrong, but what's the important question is to respond back to it. What do I need to correct that? Do I have that intelligence of the 5 whys, which means why it occurred, where it occurred, when it occurred, who was impacted, right? And for what reason did that happen? If I'm able to do this root cause, I do need multiple different types of data sets. So data sets that Guavas uses on a daily basis are things like, along with performance measurement, our fault measurement, FM data. We are also using trace data sets. We are using CDR data from the billing side. And, we are also working with ingesting data from the handset logs too, right? Nowadays, there's a lot of stress around moving away from simulated data, but moving towards actual user provided information, which can be geotagged and has a lot more granularity of data. So we do capture all of these data sets, align them on a time sequence, and then are able to extract 2 types of information. One is information which is required for tactical management, meaning what should I be doing immediately? What is the root cause? Why should I send somebody to a site, or what parameters I need to be fixing? But secondly, and most importantly, we manage a historical database of things, which means that if this problem occurred, here are the precursor events that occurred. So in the future, when we start talking about fault isolation, when we start talking about preventative maintenance, we are already moving towards that. You have a knowledge base that helps you address things before they start affecting. And sometimes that could be a big differentiator for operators.
And that's quite important, because you use past historical data. So in addition to do real time, you look at historical data to learn about the future, so that you're able to predict a problem before it arises, right? How do you do that? How do you put the learning into the system?
So, one of the key things that Guavas brings is it is a union of technology, which, we adopt from the open source community, but also two important factors that we do is that we harden this technology for scale. So when you start looking at technology coming in from an open source community, is not prime time ready. And definitely it is meant for a plethora of use cases. How does it cater to telecommunications data is something which what Guava specializes in. And most importantly, we sprinkle it with a very, very heavy influence of data sciences, which means is that when you are looking at predicting certain types of events, when you are looking at identifying whether something is out of normal, which there are n number of techniques. I'll give you a classic example. One common misconception is that you require a humongous amount of historical data to predict. There are now techniques available that you do not require the volume of history. I won't discard historical data itself, but if you think about it, historical data also has diminishing value, which means the older the data may not be as relevant today. And the newer data set that just arrived is far more important and more heavily weighted than earlier data set. So, what we try to do with our products is that any product has the capability to, go through some basic analytical capabilities like predictive capabilities, like ability to detect anomalies, ability to correlate, not just one or two or multiple, but n number of data sets together with each other, which truly, when you put it in perspective, identifies at what scale we work. There are operators where we work in ingesting more than 5 petabytes of data on a daily basis on a variety of data sets.
Yeah. So that's quite interesting. Let's look at a specific case. It's voice over LTE. And maybe you can say, sort of as an example, what happens there, because that's emerging as something that you really need to optimize. There's a lot of attention there. It's not as easy as people thought it would be.
Yeah. So, you touch a great point, which is a fantastic segue into what I was talking about earlier. A classic pain point that we are hearing from our customers is the fact that every product that they have deployed now over time, now a typical service provider's network has more than 10 different types of tools. There is a tool to do capacity planning, there is a tool to do coverage planning, there is a tool that monitors the network, there are 5 types of probes, there are 3 types of equipment vendors, etc. Now what that does is that when you deploy a tool like that, at the end of the day, a lot of these tools are consumers of data, right? They're not creators of data unless and until you are truly an equipment vendor, where you cater to the call itself. So you will be creating O&M traffic. However, a lot of these tools, when you deploy them as a stack, want yet another tap of that existing data set. So what happens is that there is a humongous amount of overhead just to support individual tools. Volte, how does that relate to Volte? I'll give an example where one of our customers was looking at Volte calls. And they had a specific tool which was meant to do real-time monitoring of Volte calls and Volte calls alone. But they found out that most of the time the tool spent in deciphering the data as Volte or non-Volte. When at launch, you have, let's say, 5% or 7% of all your LTE traffic, and LTE traffic is humongous. If you have just 5% of these calls are just Volte calls, then why would you spend your assets, which are catered to troubleshooting, and spending more than half their resources just in identifying whether it is a Volte call or a non-Volte call? If it is a Volte call, is it a troublesome Volte call or is it a normal Volte call? These sorts of questions we've tried to address with our RAN mediation product. And, with that, we try to reduce, a lot of the overheads that are currently out there in the market with, either transport of duplicate data packets or just creation of duplicate packets, or errors that arise because various different tools aggregate data differently and now do not match when you look at the same number.
Yeah. So that's a crucial way to look at it. Now, one thing is that it's emerging is that there is more and more interest in looking at trace call data. So just basically drilling down, understand what's happening end to end. But then there are also probes that mobile operators have in their network. How do you see that changing over time in terms of the balance between these different types of information?
So probe and trace data set are often confused as, the same data, which, in our view is not. Trace data set and probe data sets each have their own value proposition. One, which is probe, is a lot more granular, and, a lot of times it's the best granularity of data that's possible. You ask yourself the question, do I always need the granularity of the data that's required? Because let's be honest, probe investment is pretty sizable out there, right? If an operator has to go deploy probes to cover 100% of its traffic all the time, 24/7, it's an overkill. And, at what times do they really need to capture this data, etc.? It becomes a much more complex question, especially when you think about impact of virtualization. If the network is virtualized, where will the probe reside? Do the probe vendors have, virtual probes that can replace the same functionality as what it happens today? A lot of them is still being speculated at the moment. However, you think about the trace data sets, it's readily available. It's something that the equipment provider will give you. It's, as similar to your CDR calls on your BSS systems. So this data is available, albeit it cannot be as granular as the probe data set. From a Guavas perspective, we work with both, which means that as I mentioned to you, we have the capability to ingest this velocity, variety, and volume of data across n number of equipment vendors, whoever that may be. We provide a common platform for them to funnel that data set. On top of it, because you have that capability, the service provider now have a partner in the long run if they have a cap and grow strategy, meaning if they decide to shift away from a probe vendor and bring in another probe vendor, nothing changes on their downstream systems who rely on that data set as long as you have an alternative. And we've often been challenged by our customers to create analytics which combine trace data to help minimize the dependency on the probe data sets as well.
Yeah. Now, another thing that is becoming more important as you monitor the network and try to optimize this is the use of geolocation, so that you not only get how the quality of experience, but you relate it to a specific location. Right. What are you doing in that area?
So, Guavus, first and foremost, Guavus is not a geolocation company, sure. Meaning we do not create data which will accurately identify geolocation. We do have the knowledge base and we have the capability to do that, but we do not market ourselves as a geolocation company. We are an analytics company, which means geolocation information for us becomes a data source. Now, it's very, very important data source. And to align geolocation data with actual call events is not really a very trivial form. We've seen that operators tend to use multiple vendors for geolocation or only use part of the network for geolocation. Then you don't need to geolocate 100% of your network, right? So with Guavas, again, it offers them that ability to pick and choose whoever vendor they want. Geolocation information becomes a data source to us. We often tell our customers to evaluate geolocation partners from an accuracy perspective. Most geolocation systems currently come with a 50 meter by 50 meter accuracy, which means you could have an issue on this side of the road and the problem actually occurred on the other side. That's how much 50 meters could be. And you could then be doing an offload scenario with one partner which wasn't even needed when it in reality was yours. Hence, accuracy of geolocation system becomes a very critical part in partner selection. from a Guavas perspective, we'd love to, work with geolocation data, and we do as well.
Mm-hmm. Yeah. So it's important source of information that you have.
Absolutely.
Yeah. Now, one other change that is going to affect the way operators think about their network and look at the performance is virtualization.
Mm-hmm.
How is that changing things for you?
So virtualization, actually, every operator that we work with, has some virtualization strategy identified. Either they are far down the path, or they have made significant investments in executing over the course of the next year or a couple of years. Virtualization, one thing has been very clear so far is that it's a much more dynamic environment than what it is today. What makes it really complex is that it's an ecosystem play, meaning while the traditional classical players have their virtualization offerings, you have a whole class of innovative companies, newer players, which are bringing so much value to the table, which you don't have established relations. If you're a decision maker, in an operator, you also value the relationships, your past history with a particular vendor. Now, especially if it's an ecosystem play, all of this plays a very important part in making that decision, right? What functions do I want to virtualize first? Do I even want to virtualize? If I do want to virtualize, who is my partner? At the end of the day, actions will still be taken by the operators' teams, right? Which means they will have their tools to manage the network, virtualized or non-virtualized.
Yeah.
If those tools are something, which allow them. So if they're making a tool decision today, I tell them always look at something which can be virtualized. The tool itself can be virtualized. That's a function. That's an operations function, right? All Guavas products are 100% virtualized, which means from capturing of data to the UI can be done in the cloud, or can be done in an enterprise cloud, meaning within your firewall itself. Yeah. So we definitely see virtualization as being one of the key game changers in network transformation in the years to come. I mean, there's no avoiding it. It will happen sooner or later.
Yeah. And you're already there. So for you, it's not
absolutely.
It's in the present.
Yes. For us, yes.
Now, in closing, can you give us some what you view as the next big challenges that you are addressing at Guavus, or the industry is addressing right now, or needs to address right now?
Actually, the most immediate thing, we know newer services are being offered. We understand that VoLTE is there, voice over Wi-Fi is there, and having a path to transition 3G voice to 4G and 5G voice, so as to say, is something which is already been worked on, right? What we look forward to, and we are seeing a lot of traction in the industry, to be honest with you, is how are operators monetizing their bandwidth for non-telecommunication data sets. So IoT becomes a huge thing. Telemetric data, which when ran on that, when telemetric data is transmitted on that same network, which also carries customer sensitive data, or let's say first responder data, how do you manage the network as a whole? How does IoT become the game changer? At what point of time is it okay to transmit IoT data over that same infrastructure, or do you want to leverage something like unlicensed LTE, which is very heavily propagated out there by Qualcomm and a whole bunch of other companies? So we see that IoT is one of the key areas which can become a game changer, can be a new revenue source for the operators, and definitely something that we are trialing in various parts of the world as well. Providing how analytics can help you, monetize this new opportunity.
Yeah, well, thank you so much. I think it's you're right. This is going to be a major challenge, because IoT, it's a huge market potentially. So Anil, well, thanks a lot for sharing your thoughts with us today.
Well, pleasure to be here. Thank you so much, Monica.
So this was a conversation with Anil Singh at Guavus, and this is part of a report on core optimization and traffic management from Sensafili that was written in collaboration with RCR Wireless. Thanks all for attending, and please download the full report.